Good evening, everyone. Hi, I'm Reen Anis, Assistant Professor, Department of Computer Science and Engineering. Welcome you all to our value added course on data analytics. In Unit 1, you have explored the basics of data analytics, understood what analytics is, looked at real life applications, got familiar with different data formats, practiced some basic statistics, and even saw how tools like Power BI help us in visualization and business analytics. That foundation was meant to answer the what and why of analytics. What data analytics is, why it is important, and how tools can help us. Now, in Unit 2 and in Part 1, we are shifting our focus to the how of analytics. And for that, we will be using one of the most powerful and widely used programming languages in the world of analytics, that is Python. So, in this part of the module, our goals are simple but very important. We will learn how to set up the Python environment in our system, understand the basic structure and rules of Python programming, uh, and explore how Python handles mathematics from simple operations to more structured computations. This unit is like learning to drive before you can go on a road trip. Power BI and other tools are excellent for visualization, but Python will give us the flexibility and control to analyze raw data, perform custom operations, and prepare it for advanced analytics. So, by the end of this session, you will not just see analytics through tools, but actually start building it step by step by Python. And that's where the real fun begins. So, all right, everyone. In Unit 1, we saw that data analytics requires us to deal with huge amounts of data, use different tools, and apply statistics to make sense of it. Now, the question is, which tool can give us both flexibility and power to work with data? I'm not going deep like this, the key features, the importance, because we have already studied in you have studied in the unit 1 of this module. So I'm just here to just give you the main features of Python over here. And of course, it is a general purpose, interpreted, and object oriented programming languages, and is widely used, especially when it comes to analysis of the data. So, when we talk about the key features of Python, uh, just let me highlight it. Okay, so the first feature which comes is its readability. So it is one of the biggest strengths of Python. And I just wanted to ask a question. Have you ever tried of reading someone else writing that was very messy? So was it easy to understand? Of course, not. And just like that in programming, if code is messy, it's hard to maintain, right? So Python looks almost like English, so it's easy to read, write, and maintain. And it offers more readability of code when compared to other programming languages. Now, the second feature is its portability. It is platform independent. You all very well know that. That means the code you write on Windows can also run on Mac or Linux without any changes. So imagine you have done your project on your laptop and your company runs a server on Linux. Wouldn't it be great if your code just worked there too? That's exactly what Python gives us, portability. Now the third part is its vast support of libraries. And yes, Yes, this is the most important reason Python is used in data analytics. That is for its libraries. And instead of reinventing the wheel, you can just pick the right tool. For handling numbers and arrays, we can use NumPy, and for analysis of the data, we can use Pandas, and for visualization, we have Matplotlib and Seaborn, and for machine learning, we have Scikit-learn and TensorFlow. And why do you think having ready-made libraries is so useful for analytics? Of course, it saves our time, it's avoid writing long code, and it ensures accuracy. Now, the fourth reason, fourth key features we can say, is software integration. It means that Python can also integrate easily with other languages like C, C++, Java, .NET. This means if some part of your system is already built in another language, Python can still communicate with it. Think of it like being bilingual. You can talk to more people and connect more words together. Acts as a bridge, or you can say it acts as an intermediary or agent between two applications. Now, the last one is developer productivity. Now, finally, Python helps improve productivity. Unlike other languages, you don't have to declare variables in advance. The code is short and easy, so developers can spend more time solving problems rather than worrying about syntax. For example, what takes 10 to 50 lines of code in Java or C++, it might only takes 3 to 4 lines in Python. So this speed is crucial when analysts are working on tight deadlines. So that's where this feature is very useful for the developer. Okay, so to summarize, we can see Python is simple and readable. It works everywhere. It is portable. It has huge set of libraries for analytics. It integrates well with other systems and it increases our productivity. That is why Python has become the number one language of in data analytics. From startups to big companies, from academic research to industry projects. So moving further, now the next one, we download the Python, we install the Python in our Windows. So how we will do this? Python is available for almost all operating systems such as Windows, Mac, Linux, Unix. So we can see the different list, different versions of Python in download section. You can see. So the very step one you will do is just open your browser and type www.python.org in the address bar and press enter, and you will uh, redirect to this page. This is the home page of uh, python.org, and in the download section, when you click on it, this is the step two. All releases you can see the all versions of Python, and here you will see the latest version of Python. Just click on it and it will take you to it will download actually the external file in your downloads, and from that when you double click on it, it launch the Python installer. And remember to just add these checkboxes, especially add Python to .exe to path. And why we add this Python to path? Because so we can run Python commands directly from the terminal or command prompt without extra configuration. And after that, click the install now button. Yes, this is the button. Click the install now button, the setup will start, and you will see this progress, and yeah, you are done. After this, you have this message that setup was successful, and Python will be installed on your Windows system. I have already installed in my system, so I won't be able to just the show you the whole process. But yes, with the help of these images I can show you that this is how it works. And after the setup was successful, you can check on your command prompt that uh, it is actually installed or not, to just verify the Python installation. So in command prompt, command 9, uh, you just type this Python version dash version, and when you enter, you will see this latest version, Python 3.10. Okay, and yeah, congratulations, Python is successfully installed. Now moving further, we will install another distribution platform, that is Anaconda, and after that we will run Jupyter Notebook. So actually in the upcoming sessions we will work on this Jupyter Notebook. So yeah, just it is actually a web-based web UI environment to create notebook documents for Python and for R languages. And what is Anaconda? It is a Python and R distribution built for data science. It bundles Python plus hundreds of data science packages, NumPy, Pandas, Matplotlib, Scikit-learn, etc., and the Conda package environment manager. So use it so students don't waste time installing many packages. They get a ready data science environment. So yes, this is actually a very useful in a distribution platform for Python. And to install it, you will go to this website www.anaconda.com/download. Click on the download button and wait for the download to complete. And once it is completed, your file is ready for installation, and you just have to follow the process. You have to just click next to proceed. And yes, it will take a minutes, because yes, that package is, the platform is very the file size of the file is very big, so it takes it takes time, so be patient during that. And after you have done installing the Anaconda distribution platform, go to the start button and open search for the Anaconda navigator. And it is actually a GUI for Conda. It lets you create or manage environments, different Python versions, and you will see the different Python versions plus packages also is also available with that. And you can install and you can update packages, like you can see here some of the examples over here. You can see this cmd.exe prompt, and you can see this data node. This is the Python notebook. Then you can see over here is IBM Watson Studio Cloud, and yes, here it is this Jupyter Notebook. You have Jupyter Lab also, and PowerShell prompt, and you will see PyCharm, and lots of another uh, packages, right? So where you can control these packages and create your environment and launch your apps. Okay, you can also you see VS Code over there, and Jupyter Lab, Spider, and RStudio. So it is very good for beginners who just prefer clicks instead of terminal commands. Now, yes, you have seen here this Jupyter Notebook. So to install and to run Jupyter Notebook, just click on this launch button, and it will automatically redirect you to this screen. This is the home page of Jupyter dashboard, you can say. You can see here. You can see the list of folders which is download in your machine. And now click on this new button, and in this new button you will find the latest version of Python, and just click on it, and and click on it, and you will see this home page in front of you. And yeah, just now you can write code over here and you can run. And this is how this notebook will work. Okay. I just wanted you to show the this Jupyter notebook in my system, so that you can actually see how it all works. So just let me take a moment, because it is installing in my Windows. It is starting up. So just be patient. Yes, as I was saying that I want you to show this home page of Jupyter. So yes, you can see here, you can see the list over here which is download in your system. You have some CSV file, you have text file. Okay, and just click on this new button, and this I have this Python version, Python 3, the kernel of Python which is available, and it will redirect you to this home page. Okay, it says kernel is starting, please wait. So we just have to wait for a seconds, for a few seconds. Now it's ready. So yes, it's just write the code over here. You don't have to do all these things. Hello world. And just shift and enter. Yes, and you get your output. You can add more cells also, and if you want to delete any cell, just click on the cell and click this scissor button, this cut button, and you have your cell deleted. Okay, and you can also press this. Suppose I have right here data analytics. So you can also press this run button, and you will get your output. Okay, and this is the because I have writing code over here. So yeah, this bar has written code over here. And if you want to, just wanted to add comments or anything, you want other person to understand what you are doing in your in this notebook, so you can just click on that, and this markdown button, you can click on it, and after that, uh, for writing the comments, you can type hashtag. I'm just giving you the example. This is the heading. Again, hashtag I am teaching you the working of Jupyter. Good. Okay. This is the, just play with these all these pictures which is available in your homepage to explore these buttons, so you can understand how it will work. Okay, so I have written here, this is the list, and first we install Python. Second, I'm just seeing that how it will work. Second, we will see Jupyter notebook. Okay, just run it. Shift plus enter. Yes, and you will see here this explanation. Okay, this is the heading I'm teaching you. You can see this. So by this you can when you write this in the markdown session, so you can add the actually the explanation of what you are doing in the Jupyter notebook. Okay, so in the upcoming sessions you will learn it how we will the basic concepts will be given in for you here. So yeah, I think you have understood this working, how it will work. So it gives you a better understanding. So back to our PPT, we have almost see that how we have had a cell, right, and how these are the main two types of cells, code and markdown. Code cells is for adding code to a Jupyter document, and markdown cells is for adding text, or you can say comments, right? And when you want to delete something, you can add this button. After that, you can click the save icon or select this file and save and check for it. And to close it, select file and go to the option close and halt. You will be directed to the Jupyter dashboard and select quit to quit the server. Okay, so this is how it will work. Now back to the basics of Python, what we are studying. Now that we have installed Python and learn how to run it, let's peek inside the engine. What really happens when you type something in Python and press enter? Just okay. So actually it performs these three basic steps, right? I have not shared the screen. Just let me do this first. Yeah. So you can see this internal working of Python, and you can see these steps over here. So you can understand how this internal working of Python executes. So the very first step is the interpreter reads a Python code or instruction. So it reads the instruction actually line by line and check if it is written correctly. And what do you think if I write print hello world and just miss this bracket? Of course, it throws an error. It is a syntax error. So yes, the interpreter reads a Python code or instruction, then it verifies that the instruction is well formatted. That is, it checks the syntax, right? And exactly as Python stops right there and throws an error message if any uh, you have written the code incorrectly. So this stage is called syntax checking. So yes, this is syntax checker and translator. Now step 2, if no errors are found, Python translates our code into something called bytecode. And you have studied this bytecode in previously also, and that bytecode actually runs on almost every server, which makes it platform independent. So this bytecode, think of it like translating English sentences into a secret coded language that only Python understands. And why do you think Python doesn't directly talk to our computer in English like syntax? Of course, because computer only understands low level instructions, not human readable code. So the bytecode is actually in the form of low level language, right? So it is actually a bridge. And in step 3, we will the code will be executed on Python virtual machine. Okay, now this bytecode is actually sent to Python virtual machine, and you can imagine this PVM as the engine of Python. It takes bytecode and executes it step by step on your computer. And if any error occurs during this execution, then the execution is halted with an error message. So the whole process is like cooking from a recipe. First, you read the recipe carefully. It means you will check the syntax. Then you translate it step by step cooking actions. That is it. It is bytecode. And finally, you execute it in the kitchen. And if you miss an ingredient in step 1, you stop immediately, right? And if you burn the dish in step 3, you also stop with an error. So that's the internal journey of every Python code we write. Now these are the some basics of Python, and let's step into the building blocks. So imagine you are learning a new language like English or Hindi. You will first learn letters, then words, then sentences. Python works the same way. We start with the smallest pieces called character set and builds up to bigger concepts like Python's variables and operators. So when we talk about the Python character set, it is you know any program written in Python. It contains words, it contains statements, right? Which follows a sequence of characters. So whether these are letters in uppercase or lowercase, whether it's a number, digits 0 to 9, whether it's a special symbols, underscore and single quotes, double quotes, backslash, and white spaces. Together, these are called the character set. And when we talk about tokens, the second thing is token. So it is the smallest meaningful unit actually. This is called tokens. Tokens are like words in English. Without them, sentences don't make sense. So Python breaks each statement into a sequence of lexical components known as tokens. And you can see the different types of token over here. We have keywords, and this is called the token. The identifiers or variables, this is called the token. Operators, then we have delimiters and literals, right? So these are the five main types of tokens presented in Python. Moving further, literal. Literals are numbers or strings or characters that appear directly in your program. It is the fixed value written in the code. In other words, you can say. So these are the some of the examples. When I write this 78, so we will say that it is integer literal. When we write a number in decimals, then we can say that it is floating point literal. When we write a single character enclosed with this single quotes, then we will call that it is a character literal, and when we write the some word in double quotes, we will say that this is the string literal, right? So you know, I hope you will understand this concept of literal for in Python. Then moving further, keywords. Keywords are special words Python already understands. You have studied C language in your first year, and you are very well aware of what keywords are. C has actually, I think, 33 reserved keywords there, and we have this complete list of keywords supported by Python, right? So you can see here, but you cannot use them, and you will know the rules of keywords, that you cannot use them as the variable name, right? So you can see this, and as it is actually operator assert, break, class, continue, global, if. So these are some Python keywords which is supported by the Python. Next is operators. Operators are symbols that perform operations. So some basic operators like arithmetic operator, relation operator, we will see in brief right after that. Logical operator and bitwise operator, right? And then we have delimiters. So you can see this punctuation marks on these symbols. So delimiters actually perform a very special role. Like we can group, we can do grouping, we can assign some values, right? So delimiters are symbols that separate code elements. So you can see the list and symbols over here. Next is identifier or variable. You must have known that that variables are name we give to store data. Think of them like containers or labels or boxes. And we have some rules when we write the variable. So it must start with the letter or underscore. Okay, it can be of any length. It starts with a letter with which can be either lower or uppercase. Can start uh, can start with an underscore, but cannot start with a digit. Okay, and cannot be a keyword. So these are the some examples of valid identifiers you can see. And when I write the in some examples of invalid identifiers is here. So it shows an syntax error, that is invalid. Okay. Now these are the Python code data types. These are the fundamental building blocks you must aware. In numbers, we have integers, we have floating points, and in text sequence, we have characters, we have strings. In text sequence, actually, we have strings. Then this is the new thing in data types, sequences. We have list, tuples, and when it comes to the domain of mapping and sets, we have dictionaries as a data type, in which we insert our elements in this form, key and value. So suppose you have this table, and you have the different headers, name, age, country, right? So this will called key, and whatever be the list of every column, it will come in the value section. When we have boolean data type also, which returns true and false. Okay. And yes, you have already seen how we will start, how we will write our first basic Python program in Jupyter Notebook. And actually, the when we were just want to print these statements, so you can just write the statement print, and whatever you want to print on your screen, you can click right click sorry, write the statements and run it. Now the second function is input function. So this input function is used to accept an input from a user, like we do in C language. If you remember, when we use the function scanf, we will make the user to input something. Okay, so this input function is used to assign a value to a variable, and this is the very basic example you can see here. Basic input when you want to enter. So we have declare a variable and just write input. Okay, and enter your name and then print hello and the name with the user will enter. So suppose user enters Alice, enter your name and this will appear on your screen. Okay, and when you want to enter numerical data type, so you will write int over here, so that it will convert it into the integer data type. Okay, now Python operators. Now we will talk about operators in Python. Okay, so operators are just like the action verbs of programming. They make things happen, like we have to add something, when we have to compare something, we have to when we want to assign something, right? So you have already used them in C. uh, so you have this and basic understanding of operators, how it will works. The same concept will work here also. So we have arithmetic operators which perform basic mathematical operations like addition, subtraction, multiplication, division, modulus, exponentiation, right? So you must have known that division returns the quotient value and modulus returns the remainder value. Then we have comparison operators which compares two values and return true or false. So it is the equal. You can see this example over here. This is not equal, and greater than, less than, greater than, or equal to. Right. Then we have logical operators which combine conditional statements and return Boolean results. So logical and operator means if x and y is true, if both x and y is true, if you have known the tables, right? We have or operators, logical or operators. If either x or y is true, right, so it will return the true value. Then we have logical not operator. If the result is true, it returns false. Okay, we have assignment operators, okay, which assign something. Then this is the other list: add and assign, subtract and assign, multiply and assign. I want you to practice this. Just write the operators. Just take two variables and perform different operations on that, so you can understand how this operators will work. Assignment operators is will assign values to variables and update them in shorthand form. Then we have bitwise operators, which performs operations on numbers at the binary bit level. So we have bitwise AND, bitwise OR, bitwise XOR, left shift, right shift. Then we have identity operators, which checks whether two variables whether to refer to the same object in memory. So The operator is and it returns true if both the variable points to the same object with the same memory location. For example, x is y and is not, it returns true if both the variable points to different objects. Okay, so this is the identity operators. Then we have membership operators. It checks whether a value exists inside a sequence like string, list, tuple, etc. So you have this in operator. It will true if variables is in the list, it returns the value true. And not in operator, if variable is not in the list or string or dictionary, then it returns the statement true. Okay, the programs are just like stories. They have a beginning, middle, and end. But not every story is read in a straight line. So sometimes we make choices, right? And sometimes we repeat things. So that's what control flow is. It controls how instructions are executed. So when we talk about control flow structures, it refers to the order in which individual instructions or statements or function calls are executed or evaluated in a program. So we have three different types of control flow structures. We have a sequential control flow. It is the default flow. Actually, instructions are executed one after another. Uh, when we talk about this real life analogy, that we have a morning routine. We all have a morning routine. We wake up, we brush our teeth, take shower, and we eat breakfast. So yeah, this is executed one after another. And when we talk about decision control flow, so the program chooses a path based on a condition. So it means, for example, if it's raining, carry an umbrella, else wear sunglasses, right? So we have if else, if else, right? And repeat. And then the third type is repetition control flow. The program repeats a block of code until a condition is met. So the real life analogy is keep sipping water until the glass is empty. These are the example of a loop. What is loop actually is. So you can see there the example. We have sequential. First is sequential statements, which uh, which executes the sequence of statements one after another. And we have this example. First, we have printed hello, this is Sham, and then print this 43 second in Car Street, and you will get this output. First, you will get this line executed, and after that, you will get this line executed in your stream. Right. So, alternative or branching statements, I have already told you. When we want to, it's a decision based statements. So you must have aware of these statements. We have the simple if statement means uh, is the it is the simplest of all decision making statements. So this is the flow chart of if else statement. So it checks the condition first, and if the condition is true, then we have written over here the statement block 1, it will execute, as the other statement block 2 will execute, and after that it will exit. Then we have nested if statements. Means when we need to construct a chain of if statements, then elif clause can be used instead of else. So you can see the example over here. we will declare a variable marks which contains the value 85, and we will check the condition if marks greater than equal to 50. If it is true, then again we check the condition if marks greater than equal to 90, then print grade A plus. L if marks greater than equal to 75, then print grade A. Else print grade B. Else means if marks is less than 75. After that, else print fail. So because I have written over here marks, the value is 85. So yes, this statement will execute. It is greater than 75, so it will print grade A. Okay. Now the third one is iteration or looping constructs. So a loop statement allows to execute a statement or group of statements multiple times. Okay. So Python provides two types of looping constructs: while loop and for loop. You can see over here syntax of while loop. We will write while, and we will write condition in it. So when this condition will be true, it executes this statement, and when condition become false, it will execute this statement block 2. Okay, so it is else part of while is optional part actually. So you can see this example where we have to print all numbers from 10 to 15. So we have initialize first I is equals to 10, and we will test the condition while I less than equals to 15. Just print I. Okay, so first it will I is equals to 10, and after that we will update the value also. Update the value of I by I is equals to I plus 1. So first it is it will the initial value will be 10, uh, and we will check this condition. Yes, of course it is less than 15, so it will print on your screen. Then after it will update plus 1, it will become 11, and again we will check this condition, and it will it is true actually, then it will print again 11 over here and till 15. Okay, and after 15, when I is updated and becomes 16, the condition is tested false, and this will terminate the loop. So that's how while loop work. And for loop is the most comfortable loop, or you can say it is an entry check loop. Okay, so actually in Python, we will use this range functions which specify the initial, final, and increment values. Right? We are not using the same syntax as we are using in C. So this range function we will use. Okay. So that this range function generates a sequence of numbers which can be used to control how many times a loop runs. I mean, where you can say this start refers to the initial value, where it will start, then where it will stop. It refers to the final value, and how much increment value this step refers. So this is the optional part. Okay. So when we write this range 1 to 30, and we will take this increment value as 1, so it will start the range of values from 1 and end at 29. Okay, and when we talk about this range 2, 30, and 2, it will start the range of values from 2 and end at 28. So this is the example of range. So yes, we can see over here the example of for loop. We have written the statement for I in range 2 uh, means it will start from here till 10. And what numbers it will? Yes, the increment value will be 2. Okay, and then print I. So what we will get the output 2468. We will get this output. This is the very basic example of for loop, because these are the actually you can practice these program in your Jupyter notebook, so you can aware of this with the working of these. Okay, then we have nested loop structures. Okay, you can with the nested loop structures we can you can see here the pattern printing option program will become very easy, right? And this is the inner working. We have outer loop condition. When it becomes true, then we have inner loop condition, and when this condition is true, then we will execute this statement, and again it will come back. When it will false, it became false, then we return to this statement, and again to the outer loop condition, and again the whole process is done, right? So this is the nested loop structure. Now break and continue statements. So loops are like a train moving on a track, but what if you want to stop the train in the middle of the track? Or what if you want to skip one station and keep going? So that's where break and continue come in. Okay, so the break statement immediately ends the loop, no matter uh, what, no matter whether the condition is still true or not. So you can see this example over here, which demonstrate the use of break statement. The numbers from 1 to 10, and we have taken this loop for I in range 1 to 100, and we have this increment value 1. If I is equals to 1, and we will add this statement break. So when output appear, it will say 1 2 3. It will print 1 to 10, and as soon as this 11 appear, it will break, it will terminate the loop. Okay, the loop will be terminated. And for continuous statements, the continuous statements skips the current iteration actually and moves to the next one. So in this example, you can see the same example for I in range 1 to 11. If I is equals to 5, then continue. So when you see this output, in each iteration in the above program, the value of the variable I is checked. So if the value of I is 5, then continue statement is executed, and the statements following the continue statements are skipped. It means that part is actually not printed. That 5 is not printed, and after that it will continue the other part of the statement. Okay. Now mathematics and Python. So now that we know how to write programs in Python, let's ask ourselves, what is the heart of data analytics? The answer is simple. It is mathematics and statistics. So Python is not just a programming language. It is like a scientific calculator. Okay, you can perform basic math operations like addition, subtraction, multiplication, division. You can perform advanced math like square root, when you have to find out the square root, or you have to find out the power, logarithms, trigonometry functions. And with library like numpy and math, it becomes super powerful for numerical work. So this math module is a very important features which deals with the mathematical operations, and you can import the Python math module using the above command. So I want you to just wait a moment you to show, the, show you the Jupyter notebook where we will do this practice. I hope my Jupyter screen is visible to you all. So yes, let's get started. Moment. Okay, so we will see some basics of mathematics over here, how this module work. So first of all, we will import our math module. Okay. So we have a constant math module, right? We have constant module. Just let me show you. Okay, where we will print the statement. We have Euler's number. Okay. Then we have pi value. And we have tau function value. We have infinity. We have not a number. So, okay, we have this constant math module. Okay. So Python math module provides various sources values of various constants like pi and tau. We can easily write their values with these constants. Okay, so let's look at this example. Import math module and just print math.e. So this mat.e constant returns the Euler number. So when we shift and enter to choose import math module, what I have done, wait, sorry, actually I don't have to write this. Just write import math. My mistake. Okay, yes. So it returns the Euler number. Okay. Now next we can show import math, and when we print math.py should present, it returns the value of pi. Similarly, for tau math print math dot tau function, and it will return this value. Then we have infinity constant. It means basically something which is never ending or boundless from both directions, uh, whether it was negative or positive. So it cannot be depicted by a number actually, infinity. Okay. So for example, when we write math dot inf. When we print the statement minus math dot inf, just enter. So you will see this positive infinity, and you will see this with negative. So it cannot be depicted in a number. So it just give a constant. Okay, whether it is positive or whether it is negative, right? So again, I'm just showing this example. Import math print math.inf. Math.inf is greater than print minus math.inf is less than minus 108. Just let's see. It, yes, it says true in both statement. Okay, no, actually it compares infinity with a natural number. This example which I'm showing you. Now nan value. What is nan value? Not a number actually. Math.nan constant returns a floating point nan, not a number value. This value is not a legal number. Okay, the nan constant is equivalent to float nan. So just write again math and print. I'm showing you this in 8 separate cells so that you can clearly understand this whole concept. But you can add all these in one cell also. Okay, get the right. Now moving further, we'll see some numeric functions in math module. So numeric function in math module, what we will see, we will find the ceiling and floor value. We will find the factorial value. How we will calculate the factorial. Okay, how we will find the GCD. Okay, absolute value. So these are the some examples which we'll be going to do, which we'll be going to learn. Okay, now first of all, finding the ceiling and floor value. So import, what is seal value and floor value? Does anyone know? Does anyone know seal value and floor value? Seal value means the smallest integer value which is greater than the number, and the floor value means the greatest integer value smallest that smaller than a number. So this can easily be calculated using the seal and floor function. So we'll see here import. First of all, we will import this math library, and a is equals to, we'll just take a number 2.3. We'll declare a variable which contains the value 2.3, then print the cell of 2.3 is hence. Okay, then print, sorry, not cell, it is C. Okay, C function. Then math dot will convert the value. It will give the C value of what? 2.3. Okay, then we will print the floor value. Floor of 2.3 is ends equal to, and we will print floor value math dot floor. Okay. Now just shift plus enter and control it throws an error. It says that end is an invalid argument, keyword argument for print. Let me check. This throws an error. Check. Ends is an invalid keyword. Alright, I'll return it incorrectly. I think it should be end, not ends. Sorry by my side. Yeah. Okay. So the seal of value of 2.3 is 3 and the floor value of 2.3 is 2. Right. Uh, well, actually, what this end function does, it tells Python to end the first print uh, with a space instead of a new line. So that's how we import math. We can see this calculation of seal and floor function, floor value. Sorry. Now, when we have to find the factorial of a number, import math, you can yes, you can done the factorial of a number using recursion also, where we use the function, right? So import math, then we declare the variable a is equals to 5, then print the factorial of 5 is, and is equals to, then print math dot factorial. Just run this program and you will get this factorial of 5 is 120. So you can use directly this math dot factorial function for calculating the factorial value of a number. Now when we have to find the GCD of a number, greatest common divisor, how we will do that? Let's take this example also. Both math a is equals to 15, b is equals to 5, print the GCD of 5 and 15 is, and is equals to, okay, then print, and we just this using this function math dot gcd b comma you will get the GCD of these two numbers 5 and 15, that is 5. Alright, now finding the let's take another example, finding the absolute value. How you will calculate this A is equals to, what is absolute value actually? You will see here. A is equals to minus 10, then we will print the absolute value of minus 10 is wait a minute. Minus, then print math dot abs absolute value of a. Okay, and do shift plus enter. Yeah, again what I have done, I'm doing lots of mistake right now. It says yeah, math has no attribute abs. So yes, of course, because it's substituting point number, so I have forget f over here. Yeah, now you will get this. The absolute value of minus 10 is 10.0. So you will see that it gives the floating point of a noun, floating point SOF apps. Huh. Now moving further, we have logarithmic and power function. How we will calculate that? So when we want to use the exponential function, so we will use the exp method. So let's write import math will test integer minus 3 test float 0.00 test float 0.00, then is negative integer negative negative integer minus 3. Then print math.exp. When we write this exp, it will print the exponential value. And what is actual exponential value? I this actually exponential value. Anyone remember? It calculates the power of e, that is e to the power of I. Right. So let's do that. Maths.exp test negative integer print math.exp test float shift press enter and you will get this value. It gives the value of integer, and it gives the value of floating point number and negative integer, right? These three written integer incorrectly. Yes, this is floating point. Just integer. Actually, it calculates the value, exponential value to the power of what we have right here. Okay. So you have already. This is the e value which you have studied earlier. Also, it's a constant. Okay. So how we will calculate the power? So yes, how we will calculate the power? So import math, and after that just print the statement, the value of, you must have studied also before also how you will perform this power calculation in other languages like C or C++. So you will use this uh, double asterisk here, okay, which will calculate the power. And sorry, and we have this method function called POV, which calculate the power. So 3 4 is I'm not putting writing it. And after that print POW 3 to the power 4, and it's 80. Okay, so that's how we calculate the value of, calculate the power of a given number. Okay, and now finding the logarithm, log base e, log base 10. How we will do this? We can also be, let's take another example which will show this, how you will calculate the logarithmic number. We will import math module, then print the value of log 2 with base 3 is, and no, I'm not writing this function. Okay, it's up to you. Then print math dot log, because log 2 with base 3. This is the simple log function, okay, which returns the logarithmic value of a with base b. Okay, so here is the value of a is 2 and the value of base b is 3, right? Then we will calculate the value of log 2 of 16. 16 is and we will print math dot log 216. So this log 2 of a, what it does, this function computes value of log a with base 2. Okay, this value is more accurate uh, than this than we have discussed this before. Then again print the value of log 10 with base, sorry, of 1000, sorry, 10,000. So let's 10,000 is, and then print math dot log 10. Math dot log 10, what, 1000, right? And click on this run button. So you will get this value of log t with log 2 with base 3 is this. The value of log 2 of 16 is 4.0. Value of log 10. This log 10 function computes value of log a with base 10. Okay, so that's how we will calculate the logarithmic function. Now when we have to find the square root, okay, we have to find the square root. So let's take an example again. Import math, then print math dot sqrt on 0. Right, let's do that. Then print math dot sqrt will take integer, will take positive integer. Then print math dot sqrt, and we will take floating point number 3.5, right? And then when you shift enter, you will get this value. For 0 you will get 0, for 4 you will get 2, and for 3.5 you will get 1.87. So that's how you will calculate the you will find the square root. So this sqrt function returns the square root of the number. Now we have some trigonometric and angular functions. We have trigonometric and angular functions. So we can calculate sine, we can calculate cos value, we can calculate tan, value, and for angular functions we can convert the values from degrees. Okay. For angular function, angular function, we can calculate radian, we can like we can convert the angle from degrees to radians and from radian to degrees. Okay, so let's take an example for age. So again we will import math and we'll take the variable which contains math dot by 6. Okay, we will calculate the value, sine value, cos value of pi by 6. And the value of sine is value of sine of pi by 6 is, then we will print math dot sine of a. Okay. So this function will print the value of sine, right? Then again we will print the value of cosine pi by 6 is, and the function we will use for cosine cos, right? Then we will see the value of tangent of pi by 6 is math dot tan function we will use. Okay, and let's see, and you will get this value of pi by 6, the sine value, the cosine value, the tangent value. Okay, now we will studied about angular function. So we will perform some angular functions as well. So first of all we will use degree function. So it converts the value from radians to degrees, right? So suppose you want to convert this pi by 6 to degrees. Now, pi by 6 is in which format? It is in radian, and we want to calculate this to degrees, and also we want the value of radian, sorry, want the value of degrees to radians. Okay, so we will again import math function, and a is equals to math dot by 6. It is the radian one value, and b is equals to 30, means it is the degree value of, it is the value in degree, right? So print the converted value from radians to degrees is, and again what we will print math dot degrees, degrees of a, So it will convert the this function degrees will convert the value from radians to degree. And again, we will from degrees to radians. Yes, and we will print math dot radians a. Okay. Let's enter this shift plus enter, and yes, you will get this. 5 by 6 is 30 degree, no? So yeah, this gives this value 29.999, that is 30 degree, and we convert this degrees to radians, it will give this one. I have written wrong uh, variable here. Actually, I have to, yes, to do this 30 degree. Yes, now we got this converted value from degrees to radians. Okay, so yeah, some special functions are also there, like when we have to find the gamma value. Okay, finding the gamma value. So how you will do that? You will import math, then gamma var is equals to 5. Okay, then print the gamma value of the given argument is. What we will write over here as str str. We have to perform man dot gamma, and in which variable we have to perform, what will be the value. We will write the name of the variable here. Okay, so which is output, yes, so the gamma value of the given argument is 24. We will write here 6, and you will get this value 120. So that's how we will find the gamma value. Okay, now the next thing, if to check if the value is infinity or NaN, how we will do that. So check if the value is infinity or NaN. Okay, so how you will do this? We will import math as usual, then print math dot is in. We will use is inf function. So is this is used to check whether the value is infinity or not. We will use this function in the upcoming sessions where we will done the pre-processing of the data. So that function will mostly use there. We'll see how it works. So math dot is in inf, and is what what value we have to check, math dot by. Okay, here. Then print math dot is inf math. What value we have to check? We have to check Euler function is infinity or not. And again we will check math dot is inf um, float float and here inf. Let's see what it shows. See, I have told you na, that infinity is a constant, and it cannot be depicted in a number in the previous examples. So yes, I have written here the positive integer, right? So we'll check, and yes, um, mat dot by is not infinity or any not a number. It's a constant, so it returns false. Then same is the case for Euler function, and same, and but for this float, and I have written here in inf. So yes, it is infinity, so it returns true. I hope you have clear this. You have this got this basic understanding, right? So back to our PPT. We have here studied about what are the constants of the math module. Okay, and then we have studied arithmetic functions. We have hands-on session on that. Then we have studied power and logarithmic function, and trigonometric and angular functions are there. Now comes to the statistics module. Okay, so if mathematics is the engine, statistics is the GPS of data analytics. So with Python's statistics module, you will, you know, and libraries like NumPy and Panda, you can find the mean, you can find the median, you can find mode, and even the standard deviation. Okay. So whenever you open Python for data analytics, remember mathematics helps you calculate and statistics help you understand. So let's again let's again do wait a moment. Let's again do some hands-on session. Okay, we will come back again in our Jupyter notebook. I hope you are seeing my screen. Okay, I think you are seeing that. Yes. Okay. So when we talk about statistics module, the basic calculations we are performing, the basic calculations of the statistics, the basic concepts which we are calculating here. So just you know the concept very well, how it will. So first of all, we will calculate the mean. Okay, so we will import statistics module. Okay, and we will print statistics dot mean. I hope I have written this spelling correctly. Yes, statistics dot mean. Okay, and for what you can declare the variable over here above here also. So that's how you can also check that. So I have declared the list over here with square brackets and statistics dot mean. Whatever you know, 18, 5, 4, right? And check this number what it says. We see. I missed this bracket. I missed this bracket. 14.4. So that's how you can perform the mean value. Now, if you want, just let me explore this function also. Suppose you have declared a variable and you have 18, 5, and print it means statistics dot mean e. Yes, you can also do that. Okay, and for the you know, time is already running out, so I am just executing this in one line rather than writing it in two lines. So that's the beauty of Python. Uh, Yes, you can see this the feature right over in front of you. So now we want to calculate what another function as we want to print statistics dot median. What does median do? It returns the middle value of numeric data, right, in a list. So statistics dot median, and I'll just give these randomly numbers 1, 3, 5, 7, 9, and again 3 brackets per year. Yes, it gives me the median, and if I want to find out the mode, what is mode function? It returns the most common data point in the list. So we'll use print and statistics dot and just have the 5, 2, 3, 5. Okay. Wait, 9. Again it's throwing an error. I just write this down. So yes, we can see that 5 appears 3 times in this list. So obviously the mode will be 5. And also you can calculate the standard deviation. This, we have other functions as well. You can calculate variance, you can calculate correlation. Okay, so import statistics and print statistics dot stdep. I hope you are not getting bored from what I have doing from a very long time. I just want you to practice this, and you just want you to explore these functions so that you can understand how it will work or how it will implement. So that's why I'm showing you these examples. Some these are the basic examples actually, but I just want you to explore this because the more you will practice, the more you will understand. Take as many numbers you want. Calculate this. Now this is the standard deviation of this given elements. So back to our PPT. These things we have already discussed. Trigonometric and angular functions. We have studied statistics module. Now this part one in which we have studied the basic basics of Python. We have studied the in basics of Python. We have studied the control structures. You have studied the mathematics and statistics in Python. Moving further, we have part two in our in this unit two, that is data collection, cleaning, and pre-processing, and how we will work with text files and data. So we will see in this part how we will collect the data from different resources, how we will explore the data. I mean, from that the files are from various resources. It could be CSV file, it could be Excel file. So how we will do that, how we will explore this the data the given file, how we can do this data cleaning so, process. How we will do this data pre-processing and how we will work with text files and data. So first of all, what is data collection? Uh, and why we will do that, why we want to collect the data. Of course it will help us to understand trends and patterns, and it is very important for data analytics because data analytics is studying we will learn the patterns of data in data analytics, and after we will identify the trends and we will understand what is the pattern, we can easily make the decision. So it supports decision making process, right? And after that we can build predictive models and design algorithms, right? So step one for your data collection is you have to understand your data requirements, like which type of data do you need, whether it will be structured data, whether it will be semi-structured, or it will be unstructured data, and where you can find that data. We can just explore that. Then what will be the format and what were the constraints, right? So okay, I just want you to give the practical examples. So I'm just showing how it will work, right? So I'm again opening my Jupyter notebook. Okay, and that I will introduce I will introduce you a new library, that is pandas. So how we will learn about pandas in the next part. So be patient about that because this part is actually comes before that. So I just wanted you to give the basics over here, but the real pre-processing and we will done in the upcoming sessions where you will learn more briefly about pandas and NumPy. So I'm just here to give you the basic example, basic concepts right here. So we will import pandas as PD, okay, and now we will load our data set, right? Like we will collect our data, okay. This is the very first step you will do, and how you will do that, you have just declare this data frame is equals to and write ed dot read csv csv, and I have this csv file over here, sample students.csv. So let's explore that. Okay, sample, you have to write it in double quotes, samples, just write clearly sample students dot csv. I'll write a file name. I think I have written the file correctly, sample students dot csv. Yes. Okay. Mm, wait. And I want to now explore my data. So I want you to, I have written here df dot head. Yes. So actually I should have put it exploring. So we collect the data, okay, and how we will collect the data, we will import pandas as pd, and we will load our data set, and by how we will load the data set, we will just write this df, that is data frame pd dot read csv, and just write the file name which we want to work with. And when we write this function df dot head, it will give you first 5 rows of the data set, okay. So yes, it will give you first 5 rows of the data set, and if you want to, I'm exploring this, huh? I'm exploring the data set. I just wanted you to know what is actually df.day. Again, because yes, now this df.tail will give you the last 5 rows of my data set, right? Last 5 rows of my data set. I think I should write an example where shows first 5 rows, okay, and it shows last five last 5 rows, okay. Now I want the summary of my data set. So what I will write, df dot just give me the information. Now let's see what it shows. Yeah. So you can see here, you can see this is showing mainly some info. So you can see the headers, that is student ID, name, age, gender, city, marks, grade, right? And these are non-null values. And what type of data is it? We have integer type of data, we have float type of data. And what is the object here refers? It means the what? It means the null values. So object value refers actually to the null values. Okay. And it gives the size of view and what kind of memories it is using. So yes, you can have this summary in front of you. Right. And now df, I want to know the statistics of my data. So I'll write here describe df dot describe. What it does, it shows the summary of my statistics. Let's see. Let's see what it shows. Yes, yes, you can see here. It shows the summary of statistic, that it shows, it gives the count, right? Student ID, age, marks. It gives the mean. It gives the standard deviation. It gives the minimum and maximum value. Okay. Now, I'm just here. I'm exploring this data. Now you can add df dot columns. What it does, it shows column names. It shows column names. See, it shows columns names. And when I want to write df dot types. Okay, so it shows the data types. Right. Yes, it says that series object is not callable. Actually, it has data types object also. So yes, you have seen that. You can see the data type over here. Okay, so that's how we will explore our data. Okay, explore our data. Now, of course, in the data sets we have missing values, we have duplicates, we have erroneous data, right? We have irrelevant data also. So it will come under the data cleaning part. Okay, so now we will do some data cleaning. Just giving you, first you will check for missing values. Right? Check missing values. Now I will use the print statement. Just df dot is null dot sum. Let's see what it says. Yes, see, it shows the missing values. In the name column, you have one missing value. Then in age, you have one. Then in gender there is no missing value. Then in marks you have two missing values. Okay, so you can see now. You can see in marks we have two missing values, and in age we have one missing value, and in name you have one missing value. So either you can drop rows with missing values. We have two options. Either you can drop with missing values, or either you can fill with mean, fill with median, these things like that. Okay, so what I will do, what I will do is I'll check for option two. I'll check for option two, that is I will fill missing values. Okay, and just like we have seen here in marks, we have two missing values. So we will do df in data frame marks is equals to df data frame marks. मतलब I have declared this value variable, and in that again I'm going to the data frame marks dot fill any data frame, and to write this statement, and you will get to know what I have done. Okay, afterwards. So in I have give the reference over here, and because it's a I have to fill in it. So from which from what I have to fill to these missing values. I'll write me. Okay. So whatever the values of given in the mark section, it will calculate the mean, and then it will fill that. Okay, hashtag it will fill with mean, right? Fill with, I think it again if I want to check, let's see. Let's again see. See, after filling missing values, I have filled this marks where we have you can previously see here. This the missing values is showing 2, right? So when I have filled this marks with me, then after checking for the missing value, it gives 0. So that's how we will clean our data. Okay, it's just a basic example. And again, you can remove the duplicates also, and you can fix erroneous data also. Okay, then step 4 is after data cleaning, we will data transform. We will do the transformation of data. Means we will normalize the data, and we will standardize the data. I'm not going deeply into that because haven't studied right now pandas and NumPy. So first we will get to know the basics of that in the upcoming session, in the upcoming part. Then again we have this part that is called data pre-processing. So we will do the brief pre-processing of our data in that part, because right now you will not understand what is how we will done normalization or how we will done standardization, right? So that to our PPT. I think time is also running out. So yes, we have almost covered this part too. Okay, okay. You have studied explore the we have studied exploring the data. We have explored data cleaning, and yes, I have given this link over here in which it shows the data cleaning example through pandas. So you can get go to this link and explore how this data cleaning will work, right? And yes, this is the data pre-processing. uh, this data transformation and feature engineering are very the pre-processing techniques. We will do normalization, in which we scales our data to a fixed range, usually between 0 and 1, right? And we have standardized, we will and what how we will do that, we will import from sklearn to pre-processing import min max scaler. So this min max scaler to the normalization. We will see this in the later slides, in the later sessions, right? So be patient right now, because I just wanted you to give the basics understanding right now. Then we will see the standardization on the other hand. So what it does, it transforms the data to have a mean of 0 and a standard deviation of 1. Then we will encode our categorical variables. Okay, means we will encode our categorical variables like we have represent qualitative data, like we have types, classes, or labels. So to use these variables in machine learning algorithms, we will convert them into the numerical format. So this is called encoding categorical variables. Here is a very small example I have given here, but we will do this in the upcoming sessions. And then we will another approach is we will use label encoding. So you can see here, we will first of all we will import this from sklearn.preprocessing, import label encoder, then import pandas as pd, and we have give here this small data set. Okay, we have name and gender. Then before encoding we have this kind of data. And what we will done, we will actually we this categorical variable is assigned with the numerical. So we have assigned male as 1 and female as 0. So apply label encoding here, le dot label encoder, and how it does in that, it uh, it will uh, assign the value 0 and 1 alphabetically, because female uh, starts with F and male starts with M. So of course F uh, comes before M. So uh, F is assigned with this 0 variable, and M will assign with this 1 variable. So that's how it we will encode this. Okay, so this method is very suitable for ordinal category. That means where they are natural. So we will use this formula on gender कि आप फिट ट्रांसफॉर्म कर दीजिए, ठीक है. After encoding you will see the results over here, right? After that, how we will work with text files and data. So this is the very important functions. You have this basic syntax. We will use this open function, and then we will write file name. Okay, so we will write the relative or absolute path or the file, including the extension. Means if there is a text file called as student name, so we will write over here student name dot txt file. Okay, and that's how you will open a file and allows your program to use and work with it. So this is the first parameter. So I have seen, yes, you can see this example over here. This is the names dot text. And second parameter is what you want to do with the file. You want to read, you want to append, you want to write, or you want to create. So after this is the very previous syntax is that you have write the variable name, then open your file, and right after that comma what you want to perform. If you want to read the file, we want to write the file, just write this function. For read we are using r over here. So this is how you will read the file. Now I want you to note these exercises just to know that what things you have actually learned today. So just I want you to pause the video and note these exercises and calculate that exercises for part 1 and exercises for part 2. So I want you to pause and note these exercises and just practice it so that you can understand what things you have grabbed today. Okay, just pause and write these exercises. I hope you have write these exercises. So to what we have learned today, we have explored the data. So yes, we have studied in part 2 how we will explore the data, how we will clean our data, how we will transform our data, means how will this pre-processing works. These are some references. These are some standard books which I have preferred. You can see. That's all for now. We will continue the another session tomorrow and studied about NumPy and pandas. Okay, so thank you so much. That's all for now.